Assalamu alaikum, everyone. So today we will solve a recitation problem for chapter 3 about vectors. So this is a critical chapter and it will be used in all the coming chapters. So let's start. So please watch until the end because I will give you an assignment, self-assignment. Okay, let's start. Bismillahirrahmanirrahim. So the first problem is this problem here. So I have two vectors, P and Q, and I give you the coordinates. Okay. So the question is to find the angle that the vector 2P plus minus 3Q is making with a positive x-axis. So first, we know that P is equal to, so let me write it this way, minus 1.5, 2, and 0 along Z. I can also write it as this, minus 1.5, 2, 0 along Z. Okay. So that means that 2P, let me come back to that. So 2P, of course, will be what? This multiplied by 2, so minus 3, 4, 0. In other words, if I write it in unit vector notation, you will have minus 3 I hat plus 4 j hat. Okay, now Q, what do you know? Let's look at minus 3Q. What are the coordinates? Of course, it will be 0 along X, 0 I hat, okay, minus 6 j hat, and 0 along Z. So that means that the vector 2P minus 3Q has the following coordinates. Of course, I will add component by component. So it will be minus 3, minus 2, and 0. So now my question is, what is the angle between this vector, let me call it vector V, which is 2P minus 3Q, which has this coordinate, with a positive x-axis? So here it's easy, okay? Why? Because, you know, vector V is on the xy axis. So if I plot vector V, this is x, this is y. So vector V is in xy plane. So minus 3 is somewhere here, minus 2 is down here. So vector V is in the third quadrant. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Okay? So xy, and this is basically vector 2P minus 3Q. Okay? Of course, this is equal to what? This is minus 3. And here, this component is equal to minus 2. So now the question is, what is the angle that this vector is doing with the positive x-axis? First, I can get this angle here. Okay. Or I can say that basically theta is just tan inverse of the y component, basically minus 2, divided by the x component, which is minus 3. So you take your calculator, so you will get what? So you will get what? You will get 34 degree. But 34 degree is in which quadrant? It's in the first quadrant. So the angle that I get is this. This is 34 degree. So since my vector is in the third quadrant, I should add 180 degree. So because I was here, I need to add 180 degree, right? Which will give me this angle. So 34 here plus 180 degree. So this will give you what? 200 cos 14 degree. On the other hand, I could have said this is 34 degree, but I will retract minus 180 degree. So if I have 34 degree minus 180 degree, so this will give me what? This will give me this angle here. Let me put it in a different color. Okay, so 34 degree is here. Now, if I do 34 degree minus 180, this will give me this angle. Okay, this will give me this angle here. So that will give you minus 146 degree. Okay, so there are two ways to catch the same angle. Either I go positively or negatively. Okay, so this is my X. This is my Y axis. My vector is here. Okay, either from the positive X axis, I do this, and this angle is equal to plus 214 degree, or from this axis, positive X axis, I go in the negative direction. And this will give me minus 146 degree. So you choose, okay? You choose what you want to, either you use 214 degree or minus 146 degree. So that's the difference. Now, let's go to the next question. Now, the next question is, find the cross product, P cos Q. You know how to calculate a cross product. So P cos Q. This will give me a vector. How can I get the vector? I will first start by my determinant. I will have I hat, J hat, and K hat. Now here I will put the coordinate of the first vector. What is the first vector? P. So I'll have minus 1.5, 2, and 0 along Z. Okay. Q. What are the coordinates of Q? Of course, I will have what? 0, 2, 0. Now, how do we calculate this? And I show this in class. So first, let me change the color of my pen. You will have this. You'll have plus I hat, a determinant, minus J hat, a determinant, plus K hat, another determinant. Okay. So remember this sign. The signs are alternate. Plus I hat, which determinant? If I take I hat, I get rid of the column of I hat and I get rid of the line of I hat. So I need this determinant here. This and this. So I will have 2, 0, 2, 0 minus J hat. Now I get rid of this line and this column. So this is what is remaining. This one here. Okay, and this one. So I'll have minus 1.5, 0, and I will have here 0, 0. And then I will have plus K hat. Plus K hat, I get rid of this column here and this line here. So I need to calculate the determinant of this remaining 2 by 2 matrix. So I will have minus 1.5, 2, 0, 2. Now, this will give me what? Plus I hat. You remember how to calculate a determinant, right? This multiplied by this minus this multiplied by this. So it will give you 0 here. Here, minus J hat. Of course, you will have also 0. Okay. Plus K hat now, you will have 2 multiplied by minus 1.5. That gives you minus 3. Okay. and then 0. This multiplied by minus this multiplied by this. So at the end of the day, you get that P cos Q vector will give you minus 3 k hat. Okay. Now, finally, what is a dot product P dot Q? You know how to get the dot product. What are the components of P? You have minus 1.5, 2, 0. What are the components of Q? Of course, you will have 0, 2, 0. Dot product, of course, you will have this multiplied by this. So this plus this multiplication here plus this multiplication. So you'll have 0 minus 1.5 multiplied by 0 plus 2 multiplied by 2, basically that will give you 4 plus 0. So P dot Q is just equal to 4. Okay. Good. Now let's go to the next problem. I sent you the solution already for this problem because everything was given before, so you can go. Now here I give you two vectors, A and B, and I give you the component of A and the components of B. So let me, here in unit vector notation. So basically here I'm saying that A is equal to minus 4 I hat plus 3 j hat. Okay. And B vector is equal to 5 I hat plus 12 j hat. So what's the first question? The first question is to calculate, right? The angle between the direction of A and the direction of B. So whenever I have this type of problem, you know that I have to do a dot product, okay? Because here I gave you the component. I give you the component of A and the component of B. Component of A, let me write it in this notation. It will give me minus 4, 3. So here, if I want the angle between two vectors, I have to do a dot product or a scalar product. So what is A dot B? Of course, I have two formulas. It's AX BX plus AY BY plus AZ BZ, which is 0 here. Okay. But also it's equal to magnitude of A multiplied by magnitude of B multiplied by the cosine of the angle between them. Let me call it theta. The cosine of the angle between A and B. So what is the magnitude of A? Well, easy. It's just 4 square plus 3 square, basically 5. And I take the square root. What is the magnitude of B? Well, easy. It will be 5 square root of 5 square plus 12 square. Right? Cosine theta. Now this cosine, this is equal to what? AX BX. What is AX BX? Is this multiplied by this. So that will give me minus 20 plus AY BY, basically 3 multiplied by 12. So that will give you what? 36. So that means that cosine theta is just equal to basically 16 divided by 5 square root of this number here, which is 5 square plus 12 square. Okay, that means that theta is inverse cosine of this number. 16 divided by 5 square root of 5 square plus 12 square. So when you do the calculation, how much do you get? You get this 75.7. Okay, good. So theta will be equal to 75.7, let's say 76 degree. Okay, you can check it geometrically. Okay, you can put your XY plane, and then you put your vector A and your vector B. The angle between them will be roughly 76 degrees, precisely 75.7 degrees. Now, what's the second question? The second question is to find the component of A along the direction of B. And then find the component of B along the direction of A. So this is also a very important problem, important question. So find the component of A along the direction of B. In reality, in order to find the component of a vector along a second vector, you have to take the first vector dot the unit vector along the direction of B. Let me call it EB vector. Okay. EB vector is a unit vector along the direction of B. So let me write it here. EB is a unit vector along the direction of B. EB is equal to what? Any vector divided by its magnitude will give you a unit vector along that vector. So EB will be B divided by magnitude of B. Now let's check what is the magnitude of the unit vector EB. Of course, it will be equal to magnitude of B divided by magnitude of B, and this is equal to 1. By definition, a unit vector has a magnitude equal to 1. So a unit vector along any vector is equal to that vector divided by its magnitude. So now if I ask you the component of A along the direction of B, I need you to calculate the dot product between A and the direction of B. Okay, and the unit vector along B. So I need you to calculate A dot EB. So A dot EB will give you what? Will give you A dot B divided by magnitude of B. And this will be equal to what? AB cosine theta divided by B. And this is A cosine theta. Theta being the angle between A and B. Okay. So this we said it in class. If you remember in Al-Jalal slide, I told you that the component of A along the direction of B is A cosine theta. And the same thing, the component of B along the direction of A, B along the direction of A, so that will be this. This is equal to B cosine theta. And I gave this in class. So check it out here. So you know that EA is a unit vector along the direction of A. So that means B dot EA is just equal to B dot A divided by magnitude of A. And you will get the same thing. You will get this dot product is just BA cosine theta divided by A. The A simplify as the B simplified here, and you will get B cosine theta. Okay. Now, this is easy now. Okay. I know the magnitude of A is 5 cosine theta. I calculated theta before. So 76 or 75.7. And then I get the magnitude. I get the component of A along the direction of B. Sometimes we call it this. We call it A along B. And here I will call it B along A. Okay. So B along A here will be just 13, because you remember that the magnitude of B is just square root of 5 square plus 12 square, which is 13 multiplied by cosine theta. And I already know the angle theta, and the angle theta was 76 degree or 75.7. And then I get the component of B along the direction of A. Let me repeat that. You remember, I can write A as AX I hat plus AY J hat plus AZ K hat. What is AX? In reality, AX is just A multiply or dot the unit vector along X. And AY is A dot the unit vector along positive Y. And AZ, the component of the vector along Z direction, is just the vector A is a dot product between the vector A and the unit vector along the Z direction. Okay. So a component of a vector along another vector is just the dot product between the vector itself, A, multiplied by the unit vector along that direction. So basically X divided by magnitude of X. A unit vector along any direction is just the vector itself, X divided by its magnitude. Okay, good. So when you do that, you get what you want. So, okay, so this is what we did here. This is what I did here in the solution that I gave you. So have a look at it. This is important. So this is what I did here. Okay? This is what I did here. Some students, they know this by heart. Okay? They know this by heart. But this is coming from this, what I said. Component of A along the direction of B is just A multiplied by the unit vector along B. Okay? Which is A multiplied by B divided by B, which is A cosine theta. Good. Now let's look at this problem here. What is the magnitude of A dot A cos B? And I give you the magnitude of A. I give you the magnitude of B. And I give you the angle between A and B. So you know that this cross product here, if I call it C, A cos B is equal to C, is perpendicular not only to A, but it's also perpendicular to B. The cross product is out of the plane formed by A and B. Okay, so if this is A, if this is B, the cross product here is pointing either towards you, okay, out of the plane, or in the plane. Okay, so towards you mean this, in the plane mean this. Okay, it's perpendicular to the slides here. But because here I can use the right hand rule, so what is the direction of A cos B? It's pointing towards you in this configuration. Okay, if I had B here and A here, now the cross product A cos B will point inward because of the right hand rule. But here it will point outward. Okay. Now that means what? That means that if I take A or B cross the cross product, dot the cross product, it will give me 0. Okay. So A dot A cross B is equal to 0. Because you have 90 degrees between A and A cos B. Okay. The same thing, B dot A cos B is equal to 0 because B is perpendicular to A cos B, which is C basically. Okay, a cross product is 0, or a dot product is 0 when the angle is 90 degrees. Okay, so this dot product is 0 because you have 90 degrees between A and C, which is a cross product AB. Now ask yourself, if I ask you what is the magnitude of A cos B? If the magnitude of A is given, the magnitude of B is given, and the angle between A and B is given. So what is the magnitude of this A cos B? Always, when you have a problem, ask yourself, what if, what if, what if? So what if the question was A, what is the magnitude of A cos B? first thing first, I will do this. I will say that this is equal to C. Okay, I will say that A cos B is equal to C. So what I'm asking you here is what is the magnitude of A cos C? So you know that by definition, the magnitude of A cos C is magnitude of A multiplied by magnitude of C multiplied by the sign between A and C. Okay, so it will be magnitude of A multiplied by magnitude of C multiplied by sine 90 degree. Why 90 degree? Because as I said, between A and C, you have 90 degree, okay? Because A basically is perpendicular to C. So sine 90 degree is equal to 1. So you have just AC. Now, what is magnitude of C? So magnitude of C is just magnitude of A cos B, because I just call C A cos B. So now I will use the same thing. I will have magnitude of A multiplied by magnitude of A multiplied by magnitude of B multiplied by sine of the angle AB. And by the way, what is the sine of the angle AB? It's 63 because I said it here. So it will give me A square multiplied by B multiplied by sine 63. And you use your calculator and you will get it. Okay, so it will be 3.9 square multiplied by B, which is 2.7, multiplied by sine 63. Okay, I believe I have 73. Okay, good. And of course it will be meter cube, because you have meter in A, meter cube. Okay, so the question, the magnitude of this is 0, and I gave you the justification, it's here. Now the second question that I want to ask you is magnitude of this, and you can demonstrate that it's equal to this. Do it again if you don't get it. Now let's go to this very important problem. So a train starts from city A, first travel to city B located at 175 kilometers away in a direction of 30 degrees north of east. Remember, what does this mean? Next, it travels for 150 kilometers, 20 degrees west of north to city C. Finally, the train travels 190 kilometers due west to city D. Find the displacement of the train for the whole trip. So first, what you need to do is you plot, okay? You put your x-axis, you put your graph. We are in physics, always draw a graph, a diagram. Of course, what I told you in class, this is x, this is y-axis. X means east, positive x means east, so negative x means west. Positive y means north, negative y means south. Now let's assume that I start from point A. Let me change here the color of my pen. So what do we have? So let's assume that I start from point A. This is A, and A is at the origin. So first, what is my first displacement? I travel to city B located 175 kilometers. I give you the magnitude, away in a direction 30 degrees north of east, and I give you the direction. I give you the magnitude of the first displacement, and I give you the direction of the first displacement. Okay? So first, let's look at the direction. 30 degrees north of east. I have to look first at this. This is east. And then I go 30 degrees in the direction of north. Okay? So this is east, right? 30 degrees in the direction of north means here. So this is 30 degrees in the direction northeast. This is 30 degree north of east. You start by east. This is the east direction. You go 30 degree north of east. So this is the first displacement. I will call it D1. What is the magnitude of D1? It's 175 kilometers. So that means city B is located here. This is city B. Now from city B, I travel for 150 kilometers in a direction of 20 degree west of north. So I start by north. Where is north? This is north, right? West of north, 20 degree west of north is here. So the angle that I'm giving you is this angle here, 20 degree. So I travel for a second displacement. So let me call it D2. And magnitude of D2 is equal to what? 150 kilometers. Okay. Be careful, this angle here is 20 degree because I said 20 degree west of north. So you start in the north direction and you go 20 degree in the west direction. So this is the angle that I gave you. So now where is city C? So city C is at the end of the second displacement. So this is city C. And then the train travel 190 kilometers due west, meaning from here, I go due west. Okay, so that means I go for a third displacement here, due west. Okay, so in the direction of west. So this is D3. What is the magnitude of D3? 190. Okay, what is the direction? It's in the west direction, basically in the negative X direction. So city D is at the end. This is city D. Now the question is, what is find the displacement of the train during the whole trip? Meaning, find this vector here. So this is a total, this is a displacement. Let me call it D. So here D in reality will be equal to the first displacement plus the second displacement plus the third displacement. And I give you the magnitude and direction of the first displacement, magnitude and direction of the second displacement, magnitude and direction of the third displacement. So D here, the displacement of the train here is a resultant, meaning it's a sum of three vectors. Okay. So find the displacement means what? I have to find it in two ways. I can find it in two ways: unit vector notation or magnitude angle notation. So let's do it in unit vector notation. Look at D1 here. What are the components of D1? D1x, I know it will be magnitude of D1 cosine the angle between D1 and the positive x-axis, which is 30 degree. So this is equal to 175 cosine 30 degree. D1y, okay, it will be just D1 sine 30 degree. So 175 sine 30 degree. So this is D1x here, and this is D1y here. This is a cosine because, as you can see, it's an adjacent side, and this is a sine. Okay, this is D1y, and this is D1x. Now for the second one, for the second displacement, D2. What are the components of D2? Now here, D2x will be equal to what? D2 cosine the angle between D2 and the positive x-axis. And that angle is here. So this is the positive x-axis here. So I have to add 20 plus 90 degree. So that will give you cosine 110. Be very careful. If you make a mistake here, you will get it wrong. Okay. So it will be D2. What is D2? What is the magnitude of D2? 150 cosine 110. And you see the cosine 110, because 110 is bigger than 90 degree, is negative. You see this D2 has a negative x component. And D2y will be just D2 sine 110, which is 150 sine 110 degree. Okay? Finally, D3 is due west. So basically D3 is in the negative X direction. So basically you will have D3X is just minus 190 kilometers and 0 along Y. Yeah. You get my point? This D3 is purely along X direction and it's in the negative X. So it's minus 190. Okay. You can see it. You can say that D3X is just D3 190 cosine the angle between positive X and D3, which is 180. And cosine 180 is equal to minus 1. And D3Y is 190 sine 180, which is 0. Okay, and this is what we found already here. So that means I know D1, X and Y, I know D2, X and Y, I know D3, X and Y. So that means I know the resultant. So basically the resultant has two components, one along X and one along Y. Along X, you will just have the sum of the components along X. So it will be D1X plus D2X plus D3X. And Y will be D1Y plus D2Y plus D3Y. Okay? And you do it and you get your answer, because now I know component by component what is each displacement. So when I do this, this is what I get. So this is what I get for A. This is why I told you that this is 130 degrees. Of course, I told you how to get this. Basically, this is equal to what? Is 150 cosine 110. And I told you how to get 110 along I hat plus 150 sine 110 J hat. Okay, because this is 20 here. So I have to add 90 degrees to get the angle between the positive x-axis and the vector D2, which is what you call here B. So A is D1 here, and C here is what I called previously D3. Okay, and of course, as I told you, D3 is just has two components, minus 190, 0. Sometimes in math, we write it as this, 190, 0. You write it the way you want. You can write it in unit vector notation like this. You can write it in this notation either as a column or as a line. Okay, good. Now the resultant here, total D, is just D1 plus D2 plus D3, and you add component by component, and you get your answer. Okay, so now this is the answer in unit vector notation. Now what is the answer in magnitude angle notation? In magnitude angle notation, well, it's easy. Now I know that the resultant, total D, has two components, minus 89.7 along I hat and 228 along J hat. Okay. Now, what is the magnitude of this? Well, you know that the magnitude of D is just square root of 89.7 square, because the minus goes away, plus 228 square. This is the magnitude. Now, what is the direction? Of course, the direction is theta is tan inverse of the y component here divided by the x component here. So that will give you what? Let me calculate it. Tan inverse of the y component, 228, divided by the x component, minus 89.7. So you get minus 68. But remember, this displacement is in which quadrant? It's in the second quadrant, right? So in the second quadrant, because 68 minus 68 is this, right? Is, let's say, here. This is minus 68. But my vector, I know that it's here. So I have to add 180 degrees. because my vector is here actually. Why do I know that the displacement is here? Because I know that it has a negative x, and a positive y. So it's in the second quadrant, right? So I have to add plus 180 degree. Because this is minus 68, now I have to add 180 degree in the positive direction. Okay, to get this angle in the second quadrant. To get this angle, sorry, from the positive x-axis, this angle. Okay, so this plus 180 degree will give you 100, let's say 12 degree. Okay, and this is this angle here. Okay, sometimes I will ask you what is the resultant in unit vector notation, sometimes in magnitude angle notation, and you know how to go from one to the other. Now let's look at this problem, which is quite similar to the problem before. So I have town B. Always in this type of problem, plot your x and y axis. This is your x, this is your y. Let's say that here I said town B is at 50 kilometers east of town A. Of course, this is east, this is north, this is west, and this is south. Okay, so town B is at 50 kilometers east of town A. So that means if the origin is town A, town B is just right here. And the distance here is 50 kilometers. Now, you start from town A and you drive your car 24 kilometers in a direction of 15 south of east. So let's look at the direction first. I gave you the magnitude of your first displacement, 24 kilometers. Now, what is the direction of your first displacement? 15 degrees south of east. First, I have to look at the east because I have to look at this. Okay, this is east. South of east is, this is what I gave you. This is 15 degrees. Okay, and this is different from 15 degrees east of south. If I say east of south, this is south, and you do 15 degrees, this is the angle that I gave you. Okay, but south of east, this is the angle I'm giving you. Okay, this is 15 degrees south of east, because this is east and you go 15 degrees in this direction. Be careful with these angles. Okay, good. Now here, this is what I gave you. Now what is the magnitude of the first displacement? Is equal to 24 kilometers. Then you drive 15 kilometers due north. So basically from your point here, you just go directly towards the north. Okay, let me redo it because my graph is a little bit unclear here. Let me redo it. This is X, this is Y. Of course, positive X is east, this is north, this is west, and this is south. So this is point A, and town B is here. And this distance between A and B is 50 kilometers. Now your first displacement is 24 degrees in a direction 15 south of east. You start by east, this is east, 15 degrees south is like this. And you go for 24 kilometers, 15 degrees south of east, 15 degrees below. 15 degrees, this is east, and you go in the direction of south. So this is 15 degrees. Okay. And then you drive for 18 kilometers due north. Now let's go for 18 kilometers due north. We are just going in the direction of north. Let's say that this is 18 kilometers here. Okay, this is displacement 2, and the magnitude of displacement 2 is 18 kilometers, and the direction is directly north, okay, in the positive y direction. Now the question is, what is the minimum distance between your final location? So this is your final location, let me call it F, and town B. So basically, what is this distance here? between your final location and town B. You got it? Okay. So always draw, okay? Draw and things will be clear for you. So the distance that I want here is this. Okay. Now, my first displacement, D1, has a magnitude of 24, and I know the direction. I know also the magnitude and direction of the second displacement. Now, if I add a third displacement, I will end up town B, actually. So here I will have a kind of equality. So I will say that the vector AB is equal to what? Is equal to, see, the first displacement plus the second displacement plus the third displacement. Now the third displacement, I did not do it actually, but if I had to do it, it will be like this, D3. So this is D1, this is D2, and this is D3, and I will end up at third displacement. And that's the question. I want the third displacement. So the third displacement, D3, is just AB, okay, minus D1 plus D2. Okay. Now I will do it component by component. Well, you know AB, right? What are the component of AB? It will be 50 along I hat, 0 along J hat. What is the component of D1? What are the component? Well, you know that it will be D1, basically 24, cosine what? 15 degree. And you see this is positive. But along Y, I will have 24 minus 24 sine 15 degree. Okay. So here's this 15 degree here. You see that this component is positive along X, but along Y, it will be a negative component. That's why I have here minus. So the other way to look at it is I can say it's 24 cosine minus 15. But you know that cosine minus 15 is equal to cosine 15, and it's always positive in this case. But I will say here 24 sine minus 15. Why I'm saying minus? Because here I'm rotating in the negative direction here. Okay. Some students, they will take this angle, this big angle here. It's the same. Okay. Good. Now, D2, I know it's 0 along X and plus 18 along Y. So I know everything. So I know D3X, it will give me 50 minus 24 cosine 15 minus 0. And D3Y will give me what? 0 minus minus, so it will give me plus. Okay, plus 24 sine 15, and then I will have minus 18. Okay, so I know what is the magnitude and direction of D3. Now, once I get it, I can get, I know the unit, I know the components of D3. Now, once I get it, I'll say that, well, the distance D3 that I have to cover in order to end up at B is just square root of D3X square plus D3Y square. Okay, good. So I know everything. I know A is a component of A, B, okay, this vector here. I know the component of D1, I know the component of D2. So the only unknown is what are the component of D3. Once I get it, I get the magnitude, and this will give me the minimum distance between my final destination here, F, and the point P. Okay, good. And when you do that, you will get 29.3 kilometers. Okay, now let's go to this problem here, which is extremely important as well. So read it carefully. Always read the problem very carefully, and then. Okay, so let's read this problem very carefully. We consider two displacements, D1, and I give you the magnitude of the first displacement and the magnitude of the second displacement. Now, the question is this: what angle should D1 make with D2? Or what angle should D2 make with D1 to get a resultant displacement of magnitude 4? Okay. So let's assume this is the first displacement, D1. What is the magnitude of D1? Can you tell me what is the magnitude of D1? 3 meters. Now, what is the magnitude of D2? The magnitude of D2 is 4. So let me assume this is magnitude of D2. This is, let's say this is D2. And the magnitude of D2 is equal to what? 4. So the question is, what angle does D2 make with D1 in order to get a resultant of magnitude 4? So what is the resultant? The resultant, of course, R is D1 plus D2, is a sum vector. So this is the resultant here. Okay, and this is D1 plus D2. Okay, and the magnitude of this resultant, according to the problem, should be 4. Now the question is, which angle should D1 or should D2 make with D1? So basically, this is D1, right? So let me put it here. This is D1, and this is D2. I want this angle here. What is this angle here? Let me call it angle theta. Okay, because that's the question. What does D2, basically D2 here, either you can look at it from D2 to D1, basically this angle, okay, or D1 to D2. Okay, to get a resultant, which is here, let me put it in another color here. So this resultant here should have a magnitude of 4 meters. So look at this problem, and this is a very important problem, because here, if you see, I'm giving you a triangle, and I'm giving you what is the length of each side of the triangle. So in reality, if I find this angle here, okay, I'm done. I'll just say 180 minus this angle here will give me theta. This theta here is 180 minus this angle here. Let me call it alpha if you want, minus alpha. Okay. So here, what I have here is I have a problem that you know in geometry. Okay. Basically, when I know A, B, and C, what are these angles of a triangle? Okay. So in a triangle, you can always write a vector as a function of the other two vectors. So let's assume that this point is A, this point is B, and this point is C. I can solve this problem very quickly, but I'm just giving you a general view. So in a triangle, you always have, of course, AB plus BC plus CA is, of course, equal to 0. AB plus BC plus CA will go to 0. Okay? So that means what? That means basically here, AB plus BC is just equal to minus CA. Minus CA is just plus AC. So here, I'm just telling you that AC here, and by the way, this AC here is a resultant, is R, is equal to AB. AB is the first displacement, D1, plus D2. BC is the second displacement, as you can see. AB is D1, and BC is D2, and AC is a resultant. You can always write this type of, let's say, relationship in a triangle. So now here, I will use something very important. here actually, I want to give you 3 general formulas. Whenever I have the length of each side of a triangle, I can get these angles. Okay. Or I can give you 2 lengths and 1 angle, and you can get the rest of the angles and you can get the length as well. So this is a general framework that I want to show you. Of course, when I solve this problem, I solve it differently in these slides, but all the ways lead to Makkah. But now here I will show you the solution using a different method. So you see that R, the resultant R here, is equal to D1 plus D2. Now here, they are asking me about an angle. Let me take the dot product. So let me take R dot R. By the way, R dot R is just magnitude of R square, basically this side square. So R dot R will give me what? D1 dot plus D2 dot D1 plus D2. So R square, by the way, I know R is equal to 4. So R square, which is equal to 16, is equal to D1 plus D2 dot D1 plus D2. So this I can distribute. I will have D1 square plus D2 square plus 2 times D1 dot D2. And this will give me D1 square plus D2 square plus 2 times D1 D2 cosine the angle between D1 and D2. And that angle, that is what I call theta actually, because I want the angle between D1 and D2. And this theta, as you can see, if this is D1, this is D2, this angle theta is D1, D2. Okay, the angle between them. Of course, let me take absolute value. So bottom line, I know the resultant square, which is equal to what? 16 square is equal to D1 square. What is D1? 3 square. D2 square, 4 square, which is 16, plus 2 times D1, is basically 3 multiplied by 4 multiplied by cosine theta. So the only unknown is cosine theta. I just get it easily. Okay, so cosine theta will be, of course, the 16, and the 16 will go away. So we will have minus 9 divided by 2 times 3 times 4. And then you got theta is cos inverse, and you will get it. It will be 120 something, or 111, I believe. Yes, 112. Okay? So this theta is 112 degree. And this theta is here. Okay, 112. Okay, so theta is 112. So that means what is this angle alpha? Will be 180 minus 112. Okay, so it will give you 6 to 8 degree. So look at the formula here. Okay, now let me give you the general case now. So whenever I have a triangle, so this is my triangle. Let me call this side here A, this side B, and this side C. Okay. Let me call the angle opposite to A, let me call it A hat. Okay. It's the angle opposite to A. The angle opposite to C, let me call it C hat. The angle opposite to B, let me call this angle here B hat. Now we will write the generalization of the Pythagorean theorem. So let me call this vector here A, this vector B, and this vector C. Okay, so basically A is, so this is the vector, these are the vectors. Okay, so A is a magnitude of the vector A, B is a magnitude of vector B, and C is a magnitude of vector C. And here you see that C is equal to A plus B. Do you agree with me? Good. Okay, in this notation. Now let me calculate magnitude of C square. The magnitude of C square is just C dot C. That means what? It will be A plus B dot A plus B. So that means C square is equal to, now I distribute here, I will have A is equal to A square plus B square plus 2 times A dot B vector. So this will give me C square is equal to A square plus B square plus 2 times AB cosine the angle between A and B. Okay. Now, what is the angle between A and B? Well, the angle between A and B is this angle here. Because this is A and this is B. So this angle here is what I call theta. But theta is equal to 180 minus C, this angle C here. So I will end up with A square plus B square plus 2AB cosine 180 minus C. So cosine 180 minus C, well, you know that cosine, if this is C, this is 180 minus C. Okay, and they have opposite cosine. The cosine is this. Okay, this is C, this is 180 minus C, this angle here. Okay, so basically I'm telling you that cosine 180 minus C is equal to minus cosine C. So here I end up with C square is equal to A square plus B square minus 2AB cosine C vector, C angle. So this is a generalization of Pythagorean theorem. Okay, so here, when I know A and B, and I know the angle that is opposite to C, I can get the magnitude of C. By the way, if C is 90 degree, cosine 90 degree is 0, so you end up with C square is A square plus B square, which is the Pythagorean theorem. So in a problem, or in general in a triangle, you have this relationship. You know that A square, write this down, it's not in your formula sheet, will be equal to B square plus C square minus 2BC cosine the angle opposite to A, that I call A angle. But also I know that B square will be equal to A square plus C square minus 2 times AC cosine the angle opposite to B. And then finally, C square will be equal to A square plus B square minus 2AB cosine the angle opposite to C. Okay, and this is coming from this simple remark that in a triangle, I can define A vector, B vector, and C is equal to A plus B. And then I take the dot product. Okay, good. So that was a long, let's say, definition or a long explanation, but this is important. And you can see it in this problem here. Because in this problem, I'm asking you the same type of thing. Okay, I'm giving you the first displacement here, D1, and the magnitude is equal to 25. And I gave you the angle as well. Oh, I did not give the angle. Okay, I did not give the angle, but I just give you the magnitude. And then I give you D2. The magnitude of D2 here is equal to 30 kilometers. And then I gave you also this. So basically, I'm giving you a triangle and I give you the three magnitudes. And now I'm asking you this angle. If I ask you this angle, but the angle that I'm asking you is this angle theta actually. But you can get it using getting this angle first. If you get this angle will be just 180 minus this angle here. Okay, so I gave you a triangle with the three sides, the three magnitudes, and I'm asking you the angle between two sides. So this is what I did here. And I did the same thing as before, actually. So basically, I give you D1 and D2 square. This is the resultant square in the previous example. This is D1 square, this is D2 square, and this is 2 times D1, D2 cosine the angle theta. But the angle theta is this angle here. That's what I want. Okay. I could have solved it by saying that if I call this one A, this side B, and this side C, I will just say that, so let's assume that I want this side here. So this is C because it's opposite to the angle C. Okay. I'll say that C square is equal to A square plus B square minus 2 times AB cosine C. So that will give me 28 square is equal to A square. What is A here? 25 square plus B square, which is 30 square, minus 2 times 25 multiplied by 30 cosine C. Now this will give me C. And C will give me basically 60 degree. Now the angle theta that I want here is just 180 minus C. And this gives me 120 degree. And you see, it will give you the same answer. So this is a trick, okay? But now we have solved 2 problems. I will not trick you in the exam because now you know the trick. And I'm using the same thing here actually. Okay? I'm giving you basically sum of 2 vectors square. When do I have the sum of 2 vectors? The square of the resultant of the magnitude of the resultant equal to the sum of the magnitudes. You can only get this in a Pythagorean theorem actually. So AB square, A plus B square is equal to A plus B dot A plus B. And then you calculate and you see that this is true if only this is 0. That means theta is 90 degree. That means you have a triangle which is rectangle. Okay, which is, so basically you have this. This is C, this is A, this is B. And again, this C is A, B magnitude. Okay, and this C, you get the Pythagorean theorem. And this is true if this theta is 90 degree. Basically, it's coming from this theta. Okay, as we explained before in these 2 problems before. Okay, so here I want you to calculate this. Okay, and I want you to solve this also. And I want you to solve basically all the rest. So we will stop here. Now, the assignment that I'm talking about is here. I want you guys to solve this problem. Take a screenshot of this problem and take a screenshot of these 2 problems as well. Okay? And that's it. So these are the 3 problems that after solving all the recitation problem, I want you to solve these 3 problems. Number 1, number 2, and number 3. Okay? So please solve the recitation problems, all of them. Okay? Solve all these recitation problems. They are very important. Unfortunately, I don't have time to solve all of them, but this is critically important. Okay? Our next quiz will come out of these recitation problem and also from the assignment that I gave you. I mean, the 3 problems that I showed you. Thank you very much and see you next time.